uh, profile do you have, or what training you are currently doing?
Currently doing SAP. Uh, uh,
SAP portal.
yes.
We have SAP portal and all that kind of thing.
No, I am SAP developer.
Sorry,
SAP SAP developer.
you're a
Developer
developer.
consultant.
Okay,
Yes.
okay, consultant. Okay, okay, that's nice. So you have completed your graduation.
I did a degree. Then I changed my uh, career to IT. Like that,
Great. Yeah, that's nice. That's nice. So you are into IT, IT career now.
yes, yes, like that.
Okay, Amin. So let's just start.
Okay.
So we have seen asymmetric cryptography and symmetric cryptography. Can you just tell me the basic differences between symmetric cryptography and asymmetric cryptography? What do you think? क्या क्या हो सकता है? What do you think? What will be the differences between symmetric and asymmetric?
So symmetric cryptography has a single key, and
Right.
it is sending that key to a receiver, and
Mm-hmm.
only a single key is used. Then in asymmetric, there is private for private and public for both person
Right.
keys.
Right. And and
Uh, in
we
uh,
have here
in
single key, which is the which is only the secret key. We call it as a secret key. Okay.
Okay,
There's no
okay,
public or private key. Yeah, it's public because it's visible to everyone. But asymmetric,
okay,
it is having two keys. Okay, which is public key and private key. Next difference.
next difference.
Sorry,
Uh, Let me think. Next difference was.
what is different?
Let me think. I am thinking. What was the next difference? Uh, in the both
I'm not
case, we
getting.
can. In the both
Sorry.
case, we can encrypt anyway. Any
Okay.
any any type we can encrypt in both the case. That is a similarity between both
Yeah.
symmetric
No,
and
we don't have
asymmetric.
to see the similarity. The only the differences. Yeah, that's used for encryption and decryption. Right. But now, second difference, secret key. Here, single key is used for both encryption and decryption. Right? Right?
Yes, yes, yes.
So, we can say encryption and decryption are done using single key. But here, what happens is, I mean, in this case, how
In this
encryption and decryption is done?
uh, uh, sender will share the public key to receiver,
Yes. So
and
the public
after
key,
that,
yeah. Hmm.
After
Yeah,
that,
tell me.
that for encryption, public key.
Yeah, public key is for encryption, right?
Yes, yes.
So,
If I am memorizing the picture, then only I can
no,
catch.
don't.
So,
Yeah, memorizing picture is very good. But when we have to tell someone, okay, when someone asks
okay.
you what's the difference between symmetric and asymmetric, so you have to say encryption and decryption are done using a single key. But in this case, encryption is done using public key and decryption is done using private key, right?
Yes, yes.
Right? Any doubt?
Uh, no doubt.
Now, what's the third point? Why why we don't use symmetric but use symmetric, asymmetric nowadays? Why? Why we use asymmetric over symmetric? What's the reason? What in internet the most important thing is today in internet? What it is? What it is? Tell me.
More secure if you use
Yes,
symmetric.
exactly. Exactly. It is less secure.
Yes.
It is more secure than symmetrically. Now, fourth examples. I told you an example of symmetric. Can you just tell me? What's the example of symmetric cryptography? We have done. We
Caesar
have done a
Saif.
yes, a cipher.
Yes.
Apart from this, the most widely symmetric cryptography that was used for email protection. You know, email when I'll send you an email. So for that, initially until 2000, I think it's currently used. I'll not say they are not currently used, but in email security and small things, these symmetric asymmetrics are used. For example, email security. So we have DES. DES is not used, but AES is used a lot. AES is only a symmetric cryptography which is widely used. Okay, they are known as
Oh,
what's DES? What's the full form of DES? I think it's data encryption. No, but I'll just check and let you know. So these are the symmetric cryptography. Okay, DE and AES are known as modern. I'll not say modern. They are also of like 90s. 90s. They are invented in 90s, but they are widely used at that time and during this time, it is used because it takes less computation. How? Because symmetric keys, we need only a single key. So the computation and solving or keeping that key or the message is very uh, sorry, is efficient and cost saving. Okay, but in asymmetric, you need a large number of computations. You need, I'll tell, I have told you yesterday, we need prime numbers and that are very large. And similarly, various asymmetric algorithm apart from RSA, they need high computation and the cost related to is very high. So sometimes the experts find symmetric cryptography somewhere useful than asymmetric because it is of less computation. It is of less complexity, right?
Okay.
Getting? Yeah.
Yes, yes.
I'll tell you, I'll share my laptop screen and show you. In this, we have
Hmm.
most used. What's the name I told you yesterday? Is in asymmetric. Do you remember?
Yes, children.
RSA.
Oh, okay, okay. Yes, yes. That I didn't know.
Yes, we have RSA. We have elliptic curve. Then we have RSA, elliptic curve, and there are various. I'll just tell you. But this is the most important, and this because they are widely used in blockchain technology. RSA and elliptic curve. Write it down.
Okay.
Add fifth point also that not a fifth point. This point will be come between 3 and 4. That easy to calculate and manage. Okay, hard to calculate and manage. Write it down.
Yes, right.
Written
Fourth one, RSA and
fifth point.
RSA.
Fifth,
Fourth one,
RSA and elliptic.
EL.
PTIC. Elliptic and curve. Elliptic curve.
Oh, it is a
And this
method.
point,
Oh,
yeah,
elliptic curve is any method.
yeah,
Or
it's similar like RSA.
oh,
It is used. There are various asymmetric algorithms. Okay, RSA, elliptic curve. Similarly, in symmetric, we have Caesar cipher, DES, AES, substitution cipher, and various many
oh,
more. It's like we have this a big world, so anyone from any part of the world can contribute it. Okay, so for example,
okay.
Amin, you can create your own asymmetric cryptography and can write a research paper on it. If someone finds your this cryptographic algorithm useful, then people can get to know about it and they'll start to learn about it, right? So similarly, they all
Yes,
of
yes.
them work. People started to research about it, and then we got the most secure, which is RSA and elliptic curve. Okay.
Okay. Okay.
Written?
No, last one, fifth point.
Yeah. It's
R
easy to
to
calculate and manage. It's hard to calculate and manage.
is since okay. Good.
Okay.
Okay.
Okay. Now we'll see the concept of digital signature.
Okay.
Yes, Amin?
Oh, yes, yes. Yes, digital signature. So, Amin, suppose, or I'll say this is my signature. Okay. And there's a Okay.
document, and I'm sending this to you. So I'll just sign it. What this sign shows? What does the sign show? Can you tell me?
Uh, valid person.
Yes,
Va-
valid and authorized person has sent you.
oh,
Okay. Like in
okay.
the note I told you, it's signed by RBI because it's the authorized to regulate the money, to regulate the fiat currency, right? Similarly,
Oh,
we need a signature to make it valid and authenticated. Like this person has sent this message, has sent you this document by signing it so that you can prove its authenticity, right? And okay, you got the word authenticity.
yes.
So, yeah, we can
Proof.
prove the authenticity of it. For example,
Okay.
when you buy a product, they say scan here to know if it is authentic or not. Have you seen it somewhere when you buy a product or something? Have you seen it?
Uh, like ISI mark.
Yeah, ISMI gives a signature, but when you buy a product, for example, when you buy health products like protein powder or something, or anything like from Amazon, they do it very well. So what they do is they give us they give a scanner, they give a scan, okay, QR scan. So
Yes.
they say
Yes.
to scan to know if it is authenticated or not. So when you
Okay.
scan it, it go to your go to their website, and that website show yes, it is authenticated, right?
Oh, yes.
So there are
Okay.
various
Yes.
people. Let's see.
Okay.
Let's see, and then let me know if you find it somewhere. Okay.
Oh.
So now,
But
for
problem
example,
is
yeah,
if you
yeah, I mean,
giving we can take a photo or copy if that same signature take as a copy, it is a problem.
yeah,
A
that's the
photo is
problem.
needed for a signature.
Yeah, that's the problem. That's
Yes,
electronic signature. For
I
example,
have given
uh,
last month I have given a signature and took photo and sent for a
okay,
government or
yeah,
legal formality. So
yeah.
that I think so. What up?
No, no, no.
I didn't went there.
Okay, okay.
Without seeing
So
me, I just signed and give in a paper and take a
you
photo and
have
send it.
signed it using your pen or something in your
Yes,
laptop.
yes, paper.
No. That's electronic signature.
Okay.
Okay,
Okay.
there
Okay.
are three types of signature: the physical signature, like this. Then this, when this physical
Oh.
signature, for example, this is my signature. If I write it into, or I'll just take a photo of it, or I'll just take a printout of it, or I'll just make it on my laptop, then it is known as electronic signature.
Yes.
When your physical signature gets converted into an electronic form, then it is known as electronic signature, and it is also valid because in IT Act, India, we have Information Technology Act. Okay.
Okay.
And we all are protected under this act, IT Act. So they say electronic signature are valid signature. No one can deny it, or no one can say, no, we don't
Oh.
accept this type of signature. You have to accept it. Okay.
Okay.
But
That is
digital
difference.
signature, advanced version of signature, and it
Oh.
uses
Oh.
mathematical calculations to give you a signature. It's not like that, just
Okay.
signed. It's different
Okay.
from it. Okay.
Okay. Now understood.
So just write it down. Electric, just write it down. I'll just dictate. So, wait. Yeah. So just write it down. We have three types of signature: the physical signature, the electronic signature, okay, and the digital
Okay.
signature. Writing?
Okay.
Yeah, write
I have
it.
to write that. Okay.
Yeah, you have to write.
Three types
Yeah.
of
Oh, you didn't open your copy?
open.
Okay.
I just write it.
Okay.
Three type of.
Should I start?
Yes. Physical signature.
Yeah, the
Okay.
physical signature, the electronic signature, and the digital signature.
Oh.
Now, the physical
Yes.
signature is the same. Okay, when we just mark,
Manual.
or when we just draw our signature, then it's the physical signature. Okay.
Manually done is physical.
Sorry.
Manually done.
Yeah, manually done. Right.
Okay.
That's the correct word. And then electronic signature means when this manually handwritten note is
Yes.
converted into an electrical form, or is converted into an electrical form, or is printed out, not printed out, or is in the uh, soft copy, or I'll say not soft copy. Just write it when it is converted into an electronic form. For example, printing, okay, submitting any document or anything, or just a photo also. Then it is known as electrical signature. Write it.
Okay.
Written.
Good. Yes.
Now digital signature is very different. Okay. Digital
Yes.
signature is very different because it uses mathematical calculations and algorithm to create a signature. Right. Digital signature is different from these two signatures, as it needs mathematical calculations and algorithms to create a signature, and that is known as digital signature, and it is used for authentication in digital world. And it's a very advanced topic. Normally, we humans, I'll not say we all, but normally we people don't use digital signature. But when you are into a company or when it's of most important, then use digital signature. I'll just tell you, you have to pay for it. Yeah, because it is not issued by, for example, it's not issued like I am creating my own. It has to be issued by a certifying authority. There's a certifying authority. India also have a certifying authority who gives this digital signature. Okay.
Like government.
Sorry.
Government will issue.
Yeah, government.
Like
exactly, the government. Government is a certifying authority in India. I don't know it, but I'll let you know who is the certifying authority in India. Yeah.
I wrote till it need mathematical and algorithm to connect.
Yeah, to calculate digital signature, and it is used for authenticating. It is used for authentication in digital world. Written.
Yes.
Okay. So see, how does it work? For example, this is A and this is B. Okay, and this is you, Amin. Now suppose A sending you a message, encrypted message C. Okay, and that message when decrypted was hi. Decryption you got hi. I am A. Okay. I'm just cut shorting it. Okay. I'm just taking a shortcut. Suppose A send a message, hi, I'm A, and it will get encrypted, which is C. And then Amin will get you will get the C, and then you'll decrypt it and you get hi, I am A. Right? Now you see that encryption is there. Thus, the confidentiality is there. But what if this B also send you a message using I'll just say C1 and C2. First ciphertext, second ciphertext. Okay. And this, and I'll just a D1 and D2. Now, when you decrypt this message, it also says, hi, I am A.
Okay.
Are you understanding? B is impersonating A, that I am also A. Hi, I am A. But and Amin thinks that B is also A. So he starts to chat with B. For example, B says, I am your family, I am your relative, I am A. And please send me your Aadhaar card or send me your financial details. And you think, and you think that it is A who is chatting with you. So what you will do is you give your information to B, right?
Okay. Yes.
So that's the problem. We are maintaining confidentiality here. Okay. How? Because using encryption. But what about authentication? How do Amin get to know is that person A or that a person B? how Amin will get to know, right?
Okay.
So
Yes.
what now A will do is, don't get confusion. Cipher message is different, but before message there has to be a connection to know that this person is authenticated. So before
Okay.
sending a message in the encryption form, what he will do is, suppose this is a document, okay, or I'll just type it. I'll not say it message because you'll get confused. Okay, I'll just say message. Message is, hey, I am A. I am the original A. Okay. Suppose he has to send the initial message for making Amin know that he is A. Now here's the twist. He will have its own public key and private key, right?
Yes.
Okay. So now he'll not ask Amin's public key. What he'll do is he will encrypt his message, digital signature. He will do this digital signature. Digital signature is same like encryption, but here digital signature, you will encrypt your message using your private key, because your sign is private. Can you tell anyone that you can do my signature? Can you do this? Amen.
Sure.
No, na?
Okay. No, no.
So this signature has to be private. So for example, I'm just sending you this document. So I'll use my private key to sign it. Okay. So when I'll
Okay.
send you, so when you'll receive this document, you can see, yeah, this is signed by Mantav's private key. So I can know that this document is given by Mantavya. Okay.
Yes. Yes.
So I'm providing you my private key to digital sign the message. Okay. So I'll just
Oh.
say how do we pronounce it, or how do we say it? A has digitally signed the message using its own private key. Okay.
Okay.
I'll just dictate you.
Uh,
So
in other
now,
scenario, we are using public key, but
sorry.
here we are using private key.
Yeah,
In
here we are using private
means
key. In
okay.
this is also asymmetric. This is because we are using PA
Oh,
and DA, but it is
yes, yes.
different. It is different. That was cryptographic systems, asymmetric cryptographic system. But here it is
Okay.
asymmetric digital signature. Cryptographic algorithms are for, no, I'll not say cryptographic algorithm, but that was for encrypting the message for confidentiality. But here we are encrypting so that we know who is the authenticated person. Okay.
We are sending private key, or we are using our own key to encrypt.
We are using our private key. Okay. So when it got calculated with the message, so uh, it's not interpretable. You cannot interpret what's the private key is. Okay. You can
Oh,
just see it. Okay.
no.
So when you send this digital signature to him, okay, so
Okay.
Amin, you will use his public key, which it is public to everyone. Public key is visible to
Okay.
you, and digital signature is visible to you. This is digital signature, DS, because I'm sending you this to Amin, and told you this line is a public channel where everything goes and come. So you have public key, when you have digital signature. So when you got this digital signature, okay, now you will verify. And how this verification is done? By using A's public key. So you will decrypt it using public key of A and do this digital signature. I'll just write digital signature. This is DS. I'll just also write it here.
Okay.
You will not get confused. DS, digital signature. Then how it is? D of PA, E of DA, and M. Okay.
Oh, okay.
So when they are cancelled out with each other, there's only message M you get. Okay.
Oh, okay.
That means that this private key is getting unlocked by using public key of A, which means I'm getting the message M, which I can interpret, or I can say that this message has been sent by A only. Okay. Now
Okay.
suppose there is a person B. Okay.
Oh,
Suppose this message is, hi, I am A. Now this person also sent message to him
same.
by applying his digital signature E of, suppose he has P of B and D of B. Public key of B
Okay.
and private key of B. So he'll just do digital signature. Okay. Now, Amin, when you receive it, when you receive it, you will verify. How you will verify? You will use this key. You will use public key of this. So
Yes. Okay.
you will apply public key of A to the private key of B. So you'll apply D of P A. Similarly, PA, because we are here for verification, just to know that this is A or this is B, and this E of DB of M. Now they will not cancel out each other because they are different, right?
Yes. Yes.
So the message is, it is not decrypting. So we can say that this person is not A, but someone
Oh,
else. Okay, getting? This is how digital signature works. And once it is established, now you can send your message. Hi, I am A. How are you doing? Okay. How? Using asymmetric cryptography, where you use Amin's public key to encrypt that message. Okay. This is for
okay.
authentication. Digital
Oh,
signature is for authentication using your private key to verify that
oh,
this is you or not. Okay.
okay. Yes.
Getting
Yes.
Amin?
Yes.
So this is widely used in blockchain because, for example, I told you
Oh,
yesterday, if I have to send you 5 Bitcoin, I have to digitally sign it that this is Manteve who is sending 5 Bitcoin to Amin. Okay. When you
okay.
got
Okay.
receive it, when you receive it, or when you receive it, and I told you this is public. All the transactions are public, so anyone from the world can see. Yeah, Manteve has sent this money to Amin, which means this coins belongs to this coins belongs to Amin. Amin is the
Right.
owner of these coins. Okay, you can
Yes.
use it for verification, right?
Okay. Okay.
So
That.
when someone's I told you about tokenization of real world assets, right? So when you got the tokens, these tokens represent verification. Sorry. This token represents your authentication. For example, suppose there's a
Okay.
company who deals with tokenization of diamonds. Okay,
Okay.
you bought diamonds, and in return they gave you blockchain tokens. Now suppose that
Oh,
or that company goes bankrupt, okay, and
yes.
it goes to bankrupt and that company vanished. It got destroyed. They removed their website and everything. Now, how you'll sue them? How will you compensate the loss from
Yes.
that website or the company? So what you can do is you can take the tokens because these tokens are yours. So you can take
Okay.
your tokens to the court, okay, to your district court and another court as well, and then
Oh,
you can say that, see, this is the verify, this is the tokens you can verify. So they can verify and they'll get to know, yeah, this is the token you have bought from a company. So they'll contact to that company or the person associated with that company to give you the compensation. Okay.
okay. Okay.
So this is how digital signature is also used for verification and authentication that this is originally you. Okay.
Okay. In this case, B send message to Amen or B send message to A
No,
here.
B will send you. B will also send
Okay.
you,
Okay. Okay.
but
Then why
he will
A
use
in that
its private key.
A is private key?
Yeah,
B
sorry,
is
Amit.
private. B is private key.
Now B is private key, but
Okay.
you know,
A is
but
not
you
in this case. In this
sorry,
scenario, A is not the no relation with B.
it's there because you will now see if it is B or A. So what you will do is you will decrypt B's message using public key of A, but it will not get calculated, will not get cancelled out because only DA can be cancelled out by PA, but DB cannot be cancelled out by PA. It can only be by using PB. Getting, Amin?
Okay. Yes. Okay.
Okay, or I'll explain it again. For see, A has to send Amin a message, but before he
Okay.
has to make himself authenticated. Okay, so for
Okay.
authentication, he did digital signature of the message using its private key. Okay, now
Okay.
this digital signal will be received by Amin. You will now do verification. How do you will do verification? By using the public key of A. So
Okay.
you will do decryption of encrypted of message using private key using the public key PA and DA. Then you'll get the message. Then you can check. Yeah, this is the digital signature done by A. But for now, for example, B also send a message which is similar to A. For that, I told you I
Okay.
am A. I am A. Suppose this message is I am A. Okay.
Okay.
Now B also did wrote a message I am A, but he
Oh,
doesn't
oh,
have the private key of A. So what he does is he digital sign the message using its private key DB. Okay.
okay.
Now this
Oh,
will match this digital signature will be received by you. Now you have two digital
okay. Oh,
signature. One is this one from A and this from B. Okay.
okay.
Now
Okay.
to get to know that this message belongs to A, you will
Oh,
use its public key to each case. This case
okay.
also and this case also. And
Okay.
when you get the message M, you get to know,
Okay.
yeah, this message is from A. But when you apply public key of A to here, it will not work. It will not calculate.
Okay.
Okay.
Will not match that. Okay.
Yeah,
Okay.
it will not match.
Okay.
Getting? So he can
Understand.
say,
Yes, yes,
yeah, B is
understand.
not a right person. B is impersonating. You know the word
Okay.
impersonating. You are taking someone's identity. You are taking others' identity. Okay.
Okay.
For
Okay.
example, I got your Aadhaar card. Okay. So I went to
Okay.
a shop and say, I'm Amin, give me this. So I'm impersonating you. I'm taking your identity. Okay.
Okay.
So this is how digital signature works. So just
Oh,
draw this diagram, this upper
okay, I
one.
will drop it.
Yeah. And I'll just dictate.
PA and DA, isn't it?
P and D. Public key, private key. D means private, P means public.
Digital signature DA of M. In that in that digital signature,
Mm-hmm.
DA of M, isn't it?
Yes, E of D A of M. DA means private key.
Oh, he's sending private key, not public key to.
Public key.
Oh,
Yes. Public key for verification.
yes, okay.
Noted?
Yes.
Now you have seen we have maintained authenticity, but there is no confidentiality. How? Can you
Oh,
tell me how? Now there is no
well,
confidentiality here.
because private key is given.
No, no. Yeah, that's a one point. Private key is accessible, but it's also hidden because because private key is in the form of 1, 2, 5, 6, 3, and very large. When it is calculated by message, for example, message I am. So when you calculate this, there's a very large number. So you cannot interpret what's the private key here. You cannot say. Okay. So
Okay.
yeah, also private key is visible, no problem. But there's also an issue here. For example, suppose this is B. Now, B can also see see this digital signature, right?
Yeah, yes, yes.
Yeah, because
We
it's
can
on
also.
public
Yes.
channel. Okay. Uh, B can also see public key of A because it is visible to everyone, right?
Okay.
Now
Public
he
key
can
can be.
also verify. He can also verify digital signature of A. but I don't want to make B to verify my digital signature. I only want Amin to verify my digital signature because I'm sending to you only, not sending to B. Right?
Oh,
Right? So we
yes, yes.
here we have maintained authenticity. Yesterday we maintained confidentially. Today we maintain authenticity, but no confidentiality. Getting yesterday we have maintained confidentiality, but no authenticity, right? Because no digital
Oh,
signature. But here we are maintaining authenticity, but no confidentiality because anyone
mm,
can verify. Now we will apply yesterday's class to here. We'll apply asymmetric cryptography here also. See how
oh,
I do it. Now this is digital signature, right? Now
yes,
Amin have
yes.
its own. Amin's have its own I'll say AM because you will get confused. PADA. So I'm just saying Amin AM, the public key of Amin and private key of Amin. Okay. Now, see, I'm not sending directly digital signature now. I'm not sending you the direct signature. What I'll do is, I'll A will say, Amin, I want to send my digital signature to you, but everyone can see it, verify it. So why you can't? Why you just send me your public key to encrypt it, to encrypt my digital signature. Digital signature is also encrypted, but
Oh, oh,
can you give me your public key so that I can encrypt the digital signature like in the previous class?
okay.
So you will send me your
Oh, okay.
public key. So I'll do this ciphertext again. And what's the ciphertext? Encryption of digital signature DS using Amin's public key AM.
Same,
Getting Amin?
same, yesterday's same.
Same
Uh,
procedure.
okay, okay.
Now, now when you receive this C, which is E of P of AM, which is Amin, in the message digital signature. Okay.
Okay.
Now you will do decryption. What's decryption? Decryption of P of AM of DS using your private key.
Yes.
So they will cancel out each other. You have decrypted text as DS, digital signature. Okay. Now you have digital signature, which is D is equals to E of DA of M. Right? Now what you will
Yes.
do? Now what you'll do? Now you will verify. Now you do verification. I will do verification applying public key of A. So you will see decryption of E of DA of M using public key of A. So you will get the message M. Now you can see we have done
Oh,
confidentiality.
oh,
Now we have
oh,
done
oh,
authentication as well. Now we are doing two things simultaneously. Get it?
oh,
Any doubt, let me
oh.
know. Don't get confused. It's similar like we learned yesterday.
Okay.
But to to make it confidential, to make A's digital signature confidential, we'll apply the same algorithm that we applied yesterday, asymmetric cryptography. Okay. So
Okay.
here two
Okay.
processes are taking place. But if, first is confidentiality, which we have done using Amin's public key. We encrypted public keys of we encrypted the digital signature of A using your public key. Now you
Yes.
will decrypt it using your private key. So you'll get digital signature. Now you will use A's public key to verification. Now suppose this is a person B. Okay. He will get this ciphertext also.
Oh.
Okay. He will
Like
also
a
get this
cross.
ciphertext, right?
Like cross. A will give is public and I mean will give is public. Yes.
So now you can see he cannot decrypt this digital signature because he will need your private key, which is
Yes.
private to you. But
Yes.
before
Yes.
case, he can do this verification because it was not encrypted. It was only digital sign. But here now we can say it is confidential because I am now attaching your private key and public key to this encryption. So now this person B cannot decrypt it and cannot verify it because before verification he needs to decrypt it. Okay, and for that
Okay.
decryption he needs your private key. But
Yes.
you will not give him your private key because it is private to you, right? I mean,
Yes. Yes. The video is gone.
okay, okay, okay. Yeah, I mean,
Okay. Then I should write this.
sorry, I mean,
I should write this. Draw this.
wait, don't write this. First, I'll dictate. Okay,
Okay.
so just write it. Suppose A, A, just write. Just when I say suppose A, you have to write this way A. So this will show that
Oh.
A is a something we represent. Here we represent A as a person. Okay. Suppose
Okay.
A wants to send, suppose A wants to send his digitally signed message to Amin. Suppose A wants to send his digitally signed message to Amin.
Okay. Okay.
Now,
Written.
for this, A has to encrypt his message. Now, for that, A has to encrypt his message using its own private key. Now, A has to encrypt his message using his own private key bracket DA.
Yeah. Encrypt this message using.
Using his own private key DA.
DA. Okay.
Okay. Once
Yes.
Amin received that message or digital signed message, once Amin received the digital signed message from A, once Amin received the digital signed message of A,
Okay.
comma,
Yes.
he will verify that digital signature. He means you, Amin. He will, or Amin will verify this digital signature. Amin will verify this digital signature using public key of A, bracket PA.
Okay.
Written from next line.
Next point. Yes. What?
Make a point. Problem. From next point, right? Problem. Written.
Problem.
In this example, in this example, we are maintaining the authenticity. In this example, we are maintaining the authenticity. In this example, we are maintaining the authenticity, but
Okay.
no
Authenticity.
confidentiality.
Authenticity spelling correct. A-U.
A
Yes.
U
A-U.
P H E
Okay.
N C I T Y. Authenticity.
Oh.
C O N F I D N T I A L I T Y. Confidentiality.
Okay.
In this case, we are maintaining the authenticity, but there is no confidentiality. As written,
Yes.
as anyone can verify A's digital signature. Anyone can verify A's digital signature. Written.
Okay. Verifies digital signature.
Digital signature. What you wrote, the last line, what's the last line?
Anyone can verify digital signature.
Yeah, anyone can verify the digital signature. Next line, solution. Then solution.
Uh,
Should I dictate?
Please wait.
Yeah. Let me know when you are ready.
Okay. A solution.
Yeah, solution. To make it confidential, to make it confidential, we will,
Make
to make it confidential, A will, not we will, A will, to make it confidential, comma, A will
A will
use, A will use Amin's
use
public key. A will use Amin's public key. A will use Amin's public key PAM. Write this. PAM. This one. PAM. A will use Amin's public key PAM. A
Okay.
will use Amin's public key PAM to encrypt,
Okay.
to encrypt his digital signature. To encrypt his digital signature. A will use
Okay.
Amin's public key PAM to encrypt his digital signature. This. Okay.
Oh, okay.
Don't write it. Don't write it. When I'll just complete it, then draw this diagram. Okay.
Okay.
Now, Amin. Now Amin can. Now Amin can decrypt that. Now Amin can decrypt that cipher text or the encrypted digital signature. Now Amin can decrypt that encrypted text. Now Amin will decrypt that encrypted text using his own private key. Amin will decrypt this encrypted text using his own private key. Written?
Oh.
Written?
This A send is public key to decrypt.
Your private key to decrypt. Amin's private key DAM. In bracket, write DAM. Written?
Yes, yes.
Hmm?
Yes, yes. First, he will send his public key to to encrypt, and he use his own private key to decrypt.
Yeah, that's for encryption. And using
Oh,
own private key for digital signature. Okay.
okay,
Basically, we
okay,
are encrypting this digital signature.
okay.
Okay. So this is how confidentiality is maintained. Right. This is how confidentiality is maintained. Written? Written?
Yes, it's maintained.
Now, when we have the digital signature of A, because we have decrypted this message. Now that we got the digital signature of A, now that not we, now that Amin got the digital
Okay,
signature of A, now Amin will get the digital signature of A. He will verify that digital signature. He will verify that digital signature. He will verify that digital signature using A's public key PA. Now Amin can verify the digital signature using A's public key PA.
okay,
This is how authenticity is maintained, right?
okay, okay. P
Written?
capital
Okay.
PA.
So Amin, yeah,
PAP. Okay.
PA,
Uh,
right?
this
So you
this
have
is
any
how
doubt till now? Let me know.
authenticity is maintained.
Yeah, authenticity is maintained. Before that,
Okay.
confidentiality is maintained. So I'm making you dictate so it is easy for you. Okay. So in this case, confidentiality and authenticity both are maintained, right?
Yes, yes, yes. Understood. Right.
So you have any doubt? Just draw this diagram.
Okay.
When you go back or not go back and you just revise it now, just read it what I have dictated and then see this diagram. Okay, you get an idea.
Okay. Okay. Yes, yes. That one is PAM and DAM in Amin case.
Yes.
That one, Amin case.
I mean,
In PAM,
yours. Yes.
yes.
P and small am. Similarly, D small
Oh,
am. Amen.
oh, oh, oh.
And always remember, Amen, make diagram in uh, in order form. Okay. First this diagram, and then this, and then this. Don't just write line by line. It will get confused. He said DAM. DAM. Okay.
D is equal to DAM or DDM?
Sorry.
DA. That
Here.
D is, D is equal to DAM of EPAM. That
Yeah.
one.
This is how we say it. Decryption of the ciphertext, which is this. Decryption of the ciphertext using
Oh,
Amin's private key. DAM.
oh, okay, AM. Okay.
Yes. And once you decrypted that message, okay, then you will verify using his public key.
Oh, DA.
DA. PA and DA last. So this is how we are utilizing both
Mm.
confidentiality and authenticity. Confidentiality by using recipient's public key, PAN. Okay.
Okay.
So you were asking from yesterday itself, like there's no use of there's use no of sender's public key and private key, right? You were asking me yesterday.
What
So
use
this
of?
is the
Oh,
example where both is used.
oh, oh, oh.
Amin's
I see.
public key and decryption key is also used, and A's public key and decryption key is also used.
Oh, yes.
One is for confidentiality and one is for authentication.
Oh, confidentiality. Okay.
Written.
Yes, sir. Yes.
So we have our own digital signature standard, and it is a standard which is used widely and in world, which is RSA digital signature. Because see, it's similar to asymmetric cryptography, but we, not we, but the whole world uses a standard basis DSS. It is known as DSS, Digital Signature Standard, and it is, and in this we use RSA cryptography. So as so to
Oh,
calculate the digital signature. Okay, and now, how do you think who give this private key? Who give this private key to Amin, to the one who wants to digitally sign the message? Who provide this private key? Then this private key is provided by a certifying authority. Okay.
okay. Okay.
Getting it?
Yes, sir. Yes.
Okay.
Oh, oh.
And you must be thinking how these public keys are public to everyone, right? We have drawn
Oh,
this, we
yes,
have
yes,
made this diagram.
yes, yes.
Okay. So the last concept, to make it more clear, how we exchange public key with each other. So there's a directory over router. You know what is router? Where all the internet gets connected and then go to other place. So there is a
Okay.
directory.
Okay.
There's a directory. Suppose this is Amin. This is Mantavya. This is Charan.
In
And this is Anish. Sorry, Amin.
in modem only it will convert to digitally, and then
Sorry.
router also. In modem
Huh?
only it convert signal will convert to digitally. In modem also it is done same
In
case.
what? In what?
In modem only it will convert to digital. In router also it will like same.
Yeah,
It is
no, router is just a port where all the internet got connected. It's
oh,
like a bridge. Okay, routers. So there's a directory where everyone's public key is stored. For Amin, public key is PAM. Mantavya's public key is PM. Charan key is PC, and Anish public key is AN. Now, for suppose, and this is all we are. This is Amin. This is Mantavya. This is Charan, and this is Anish. This is all we who have internet and are using laptop, mobile. So, for example, Amin wants to send Mantavya a message. So he can take Mantavya's public key from this directory. Suppose this is Anish. Anish wants to send message to Charan. Then Anish can take Charan's public key from this directory. So this is how a directory is maintained over the routers and the internet to make the communications available, because this is public key. So this is how public key are maintained. Okay,
oh, okay.
heading.
Oh, oh,
Okay, Amin. I think we are good to go for today.
yes, yes.
Okay.
Okay.
When you have to go for your job, at what time? 10 a.m.
Yes.
Okay, okay.
After
Yeah.
9:30 it is
Okay,
time.
after 9:30. And
Yes,
what's the
yes.
time? Okay, oh, it's 9:30.
Okay.
You don't have to go.
Yes, I have to. Okay, then
Oh,
I leave.
then you must have told me that I
Oh,
have to
I
go.
forgot. But it is the first time, so I thought I can sit.
Okay, 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 no problem.
Oh, that time.
Okay, we'll take care of this from tomorrow. Okay.
Okay. Okay.
Okay. Okay, Amin. Have a great day.
Yes.
Bye.
Okay. Okay. Bye.